All right, today we're going to break down something that's at the very heart of algebra. But we're going to do it in a way that's super simple, visual, and, well, kind of fun. Let's get right into it.
So, picture this. You're at a playground and you see this seesaw, but it's perfectly balanced. And on one side, there's a mystery box. The big question we're going to answer today is, what's inside it?
Let's get a closer look at what we're dealing with. Okay, on the left side we have our one mystery box, plus 3 stones. And over on the right side, there's a pile of 7 stones. Now, the most important thing to notice, it's totally level. That means the weight on both sides is exactly the same.
And believe it or not, this simple little toy is the perfect way to think about a mathematical equation. Because really, that's all an equation is. It's just a statement that says, hey, these two things are exactly equal. It's a balance scale, and our job is to keep it level. Let's really break that comparison down. The pivot point right there in the middle, that's our equal sign. Everything on the left of it is what we call the left-hand side of the equation, and everything on the right, you guessed it, that's the right-hand side. Simple, right?
Now here's the most important part. If you remember one thing from this, make it this. This is the golden rule of algebra. To keep everything fair and balanced, whatever you do to one side of that seesaw, you absolutely must do the exact same thing to the other side. No exceptions.
For example, let's say we just randomly add another stone to the left side. Whoops, the whole thing tips down, right? The balance is totally broken. So how do we fix it? Easy. We just have to add a stone of the exact same weight to the right side. And just like that, we're perfectly level and equal again.
Okay, now that we know the golden rule, let's get back to our original puzzle. How can we use this super powerful idea of balance to figure out exactly what's hiding inside that box?
Well, our goal is pretty simple. We just want to get that mystery box all by itself on one side. So the action we need to take is to remove those 3 extra stones sitting with it. But remember the golden rule. If we take 3 stones from the left, we've got to take 3 stones from the right too, to keep it from tipping. So let's do it. We take away 3 stones from the left side, leaving just the box. Then we immediately take away 3 stones from the right side. The seesaw stays perfectly balanced the whole time. And now we can see exactly what the box is equal to. And there it is, our answer. The mystery box on the left is now perfectly balanced by the 4 stones that are left on the right. It's the only thing that makes sense. The box must have the same weight as 4 stones.
But you know, in math, we never just stop at the answer. A super important step is to always check your work. So let's plug our answer back into the original setup. If the box is really worth 4, does the left side still equal the right side? Let's find out.
Okay, let's do the math. On the left-hand side, we have the box, which we're saying is 4, plus those original 3 stones. And yeah, 4 plus 3 equals 7. And on the right-hand side, it's always been 7 stones. So 7 equals 7. It balances. Our solution is totally correct.
And honestly, that's the whole idea right there. It might seem a little basic when we're talking about stones and seesaws, but please don't underestimate how powerful this is. This one simple idea, whatever you do to one side, you have to do to the other. It's the master key that unlocks pretty much all of algebra.
So, the final thought I want to leave you with is this. We just use this rule to balance a few stones. But what happens when the things you're trying to balance are a little more complicated? You know, like figuring out the right path for a rocket or building a financial model. Turns out, this exact same simple rule is at the very heart of all of it.